This question belongs to algorithm subject and was asked in GATE CSE 1992. So the question states, let T be the depth first tree of an undirected graph G. So we have an undirected graph G and we have a DFS of that, which is a tree T. T is a tree. An array P indexed by the vertices of G is given. P of V is the parent of a vertex V in T. Parent of root is the root itself. Give a method for finding and printing the cycle formed if an edge uv of G not in T, i.e. H belongs to G minus T, is now added to T. Okay, so now what this is saying is that for this graph we will have a DFS tree. We will have a DFS tree called T. It won't have any cycle. The tree will look something like this. It won't have any cycle. Now suppose give a method of finding and printing cycle form if an edge uv of G not in T. If now it is saying if we add a edge, let us suppose this edge is added which is not in T. If a new edge is added which is not in T and E belongs to G minus T, which means the edge which was not present, then we need to find and print this cycle. We need to actually print this cycle. This one over here, this cycle. We need to print it. Okay. Time taken by a method must be proportional to the length of the cycle. Describe an algorithm in Pascal C-like language. Assume that the variables have been suitably declared. Okay. So we basically need to just give an algo. So see, how can we do this? Suppose we have a graph like this. Okay. We can take any graph. Okay. Let us assume it's vertex 1, 2, 3, 4, and let us take this as vertex 5. Or let me use a different color so it do not make any confusion. It is vertex 1, 2, 3, 4 and 5. So what is the DFS for this? DFS of this will look something like, there can be many DFS. Let us take any one DFS like this one, 3, 4, and then I should connect this. So any edge can connect. Let us assume this one will connect this. Now it is saying if we add a new edge, let us suppose this edge is added. This is a new edge added. Then we need to detect this cycle. Which cycle we need to detect? 1, 2, 3, 5, 1. This cycle we need to detect by an algo. So how the algo will go like? I will write the algo over here and demonstrate it to you on the left hand side. So what we will do? Initially we will mark all vertices with let us assume green color is given with green color, with blue color. Okay, let us assume with blue color. We mark all the vertices with blue color. And let us assume white only, with white color. White color. Okay, so all the vertices are initially white. Now start DFS from any vertex. Okay, let us assume we start from 1. Okay, so we start from 1. Okay, now if vertex is white means non-visited, then make it any other color. We can assume, make it blue, make it blue and push to stack. Okay, so we have a stack. So what we will do, we will make this vertex as blue. So 1 is made blue and push to stack. So we will have a blue vertex 1 over in the stack. Okay, now what we will do, go to neighbors of this new vertex. Okay, so we go to any neighbor. So either we can go to 5 or we can go to 2. Let us assume we go to 2. Now again this vertex is white, so we make it blue. So this is made blue and push to stack. So we have 2 over here. Now we can go to any neighbor. Let us assume we go to 3, make it blue as it is white and push to stack. Now we go to the next neighbor, either 4 or 5. Let us assume we go to 4, make it blue and push to stack. Now There is one more condition. If no neighbor, make it black and pop from stack. So 4 do not have any neighbor, so we color it black. So this one is colored now black, not blue, and we pop it from the stack. 4 is popped from the stack. Okay. Now where we go? We go to the stack top 3, its neighbor. Any unvisited neighbor it has? Yes, it has 5. Okay. So we go, make it blue and push it to the stack. Okay. Now any other neighbor it has? Yes. Now there is another condition. If we encounter a blue neighbor, then cycle detected. See, what does this blue mean? Blue means it has already been visited, which means we have come back from another part to the same vertex. So one is already visited, which means a cycle is detected. Now stack contents are nodes in cycle. So what are stack contents? They are 5, 3, 2, 1. There is a cycle 1, 2, 3, 5. 1, then 2, 1, 2, 3, 5, and then again 1. So this is our cycle. Now what we need to do? We need to make sure that it runs in according to the length of the cycle. Okay. So let us see the complexity. Suppose we have v vertices in this. Now when we create a tree, then tree will have how many edges? It will have number of edges equals to v minus 1. Now we are adding an extra edge. So number of edge becomes equals to v. This TFL will have number of edge equals to v and number of vertices equals to v. And what is the complexity of DFS? It's order of number of vertices plus number of edges. What is number of edges? It's v. So we get order of 2v, which is equals to order of v. So it is approximately equal to the length of the cycle. So we have got our algo. This is our algo. This is our complexity.